Hello, in this video I wanted to talk about problem 7.2 from chapter 12, and this problem deals with advertisement. Alright, whenever we think about advertisement, the key thing is trying to figure out what the marginal benefit of advertisement is versus the marginal cost. That is, can you increase your profit by more by advertising than it costs you to advertise? All right, so here's the question. The monopoly faces the following inverse demand function. P equals 100 minus Q plus A to the power 0.5. Now, I just want you to spend some time on this inverse demand function. Obviously, it says here that as you produce more and more, your price is going to have to go down. But what this last term, the advertisement term here, says that if you advertise, you'll be able to shift the demand curve out, right? So if you advertise, you can sell more units for the same price. All right, so Q is the quantity, P is the price, A is the level of advertisement. The cost of one unit of advertisement is 1, and the marginal cost of your product is 10. And the question is, how many units should a monopoly produce, and how much advertisement should it do? All right, so here's I'm going to draw a diagram here to try to show you the intuition behind this kind of problem. So we have a inverse demand function, so that will be equal to start. Okay, so I'm going to draw. So I want to be a little bit careful here. So I'm going to draw the inverse demand function when first A equals 0. All right. If A was equal to 0, then our inverse demand function would go from 100 to 100. We would have a marginal revenue curve that would hit this edge here at 50. We have a marginal cost that would be 10. And what we would do then is we would find where marginal revenue goes marginal cost. That will be our quantity. We will go up here to find what the price should be. And then we would have, let's just shade that in with a green here. This will be our profit if we did not advertise. All right. So if we advertise, what happens is you can shift out the demand curve. So your demand curve would shift out something like this. You would recalculate your marginal revenue curve. You would find with the advertisement what how much you can sell at what price. You would go up and find your price with advertisement. And you can see here now that you would add this yellow area would be the increase in profit from advertisement. All right, so what we have here is basically the marginal benefit of advertisement would be this additional profit. And then, of course, the cost of advertisement will be equal to 1 times the units of A that you're going to be doing. So, again, this is the marginal benefit. This is the marginal cost. And what we're trying to do is find a level of advertisement where those two will be equal to. Remember, whenever the marginal benefit equals marginal cost, it's always our optimizing choice. So if we were to write a profit function for this problem here, then of course we would have our revenue, price times quantity. We will subtract out the cost of producing the good, which would be the marginal cost, times the quantity. And then we'd also have to subtract out the cost of advertisement, or it will really be 1 times A here. This will be our profit. So I'm going to go ahead and solve this problem now on the next page. All right, so I rewrote the profit function here, and I substituted in the marginal cost, which was 10. All right, so I need to do one more substitution. I need to write what the price is equal to. So we know that the inverse demand had 100 minus Q plus A to the power 0.5 That's the price times quantity minus 10 times quantity minus A. All right, so that's our true profit function. And what we're trying to do here is maximize profit with respect to quantity and advertisement. And then we're going to solve those expressions simultaneously. So I take the derivative with respect to quantity. So again, we have to be a little bit careful here. So we have 100 minus, multiply that in. So be, obviously we'll have q squared, and therefore the derivative will be 2q. And if we take the derivative of this one here, it would just be equal to a to the power 0.5, of course. And then derivative with respect to quantity would be minus 10, and we're going to set that equal to 0. And then we take the derivative with respect to advertisement. Here we have to be careful. We take so we have a to the power 0.5 times q. So if you take the derivative, it will be 0.5 times q times a to the negative 0.5. And then the derivative of a there is just 1, and that's going to be equal to 0. All right, so now we have two equations in two unknowns. So we'll have to solve them simultaneously. So I'm going to solve the bottom one first. So what we have here is, of course, 0.5 q times a to the power negative 0.5 equals 1. A to the power negative 5 equals 0.5 q. Now I'm going to plug this into my first equation, which gives me 100 minus 2q plus 0.5q minus 10 equals 0. So I plug this in for the a to the power 0.5 here. So then I have 90 minus 1.5q equals 0. Q equals 90 divided by 1.5, so Q equals 60, right? And then from here I can figure out what 0.5, a to the power 0.5 is equal to, which is 0.5 times 60 equals 30, and therefore A is equal to 30 to the power of 2, A is equal to 900. All right? Once I know, so now we have the optimal quantity, we have the advertisement. I just need to find what the price is going to be so I can calculate what my profit will be. Oops. So my price is going to be equal to 100 minus Q, which is 60, plus a to the power 0.5, so it'll be 900 to the power 0.5. So that is equal to 100 minus 60 plus 30. So that's 40 plus 30. Price is going to be equal to 70. All right. So if I have the price 2, I can use all that stuff to calculate what the profit will be equal to. Oops. So profit will be equal to price times quantity. So that is 70 times 60 minus the marginal cost times quantity. So 10 times 60 minus the cost of advertisement, which is 1 times 900. Let me write that a little nicer. All right, so 70 times 60, that's just 4,200 minus 600 minus 900 equals 2,700. There we have our profit. That's really what I wanted to find. Let me just, what's the profit if we did not do any advertisement, just to check for fun. So if we did not do any advertisement, then our profit, our inverse demand function first will be equal to 100 minus Q, and therefore revenue will be equal to 100Q minus Q squared. Marginal revenue will be equal to 100 100 minus 2Q, set that equal to marginal cost. And we know that our Q would then be equal to 45. And our price would then be equal to 100 minus 45, so it would be 55. And our profit will be equal to 55 minus 10 times 45, which is equal to 2025. All right, so we can see here if we were to compare all these. So we would, if we didn't advertise, we would sell fewer units, but we wouldn't be able to charge as high of a price, and therefore our profit would be a lot lower. All right, so for this case, advertisement pays off, and you're able to make more money through advertisement. Thank you very much.